Right, excellent. So yeah, thank you very much to Kate et al. For inviting me along. It's really interesting. We're based up in Hawes in the middle of North Yorkshire, up at the top of the beautiful Wensleydale. We're probably the biggest company focused on renewable energy that you've never heard of in the Yorkshire Dales. Very lucky to be based where we are and to do what we do. So if I give you a little bit of background on the company, we've actually been in this space for around 20 years now, stemming from being a contractor and installing various technologies. And that ranges from oil and gas as well, back in the bad old days. We moved quickly into the renewables. We used to work for quite a lot of very bespoke clients who wanted to be involved in renewables, even back in sort of 2003, 4, 5. So a very long time ago. And I started doing a bit of teaching up at CAT, if anybody's aware of CAT, the Centre for Alternative Technology in Machynlleth in Wales. Yeah, there's one or two nodding there. And realised that there was probably a need for something that was a little newer and a little bit, I say more accessible, right? I mean, where we live is beautiful, but not everybody who comes here thinks that we're accessible. And we've sort of expanded from there, and we've done loads and loads of really interesting things, including building a building in 2010, which was BREEAM Excellent. If that means anybody, it means anything to anybody, that's pretty much the highest sort of achievement you can do for low carbon buildings. And over that, we've become we are now the single biggest training provider of renewable technology in this country. And we deliver something like 3,500 to 5,500 training day places to people all over the UK, day in, day out, day in, day out. That's pretty much all the business does. So really proud of that. So making a difference, but perhaps in a slightly different way, by empowering those with the knowledge and information to make the changes. I'm aware you're going to slide these shares. You're going to share these slides afterwards, so I won't go through all of those, but notably, for those of you with keen eyes, we've done things like for the United Nations back in 2012. We went out to help them to decarbonize some of their ex-military sites. We have run many government incentive schemes for training, where we've distributed training funds across the UK for people. And we've also been very heavily involved in standards and compliance. So pretty much all of the national standards that are used at the moment for the deployment of these technologies are those that I've either personally written or have been written by a cohort or a group working alongside me. So the very first national standard for solar PV was one I produced in 2012 with a colleague up in Penrith. So we flew the Northern Flag all the way there, all the way down to whatever it was, DTI, I think possibly then, or DEC. Work very closely alongside government policy, government agencies, so we'll get a lot of good insights from that work as well. Well, I'll let you read up and pick up on some of that stuff. Still very heavily involved in standards, and I sit on a couple of national and worldwide committees for solar PV and energy storage currently as well. So what Kate asked me to do is to give a bit of a highlight over heat pump deployment challenges, etc. And it's actually a number that we don't hear a lot anymore, mainly, frankly, because Boris got a little bit embarrassed by it, but also because the new government hasn't quite decided if it's realistic. I can tell you now it's not, but bandied around a few years ago, there was a term of delivering 600,000 heat pump installs by 2028, which is just an absolutely colossal number of heat pump installs. I don't quite know what everybody I'm speaking to now wants to know, so I've got picked out a few key points from a few key areas and happy to dive into that on Q&A afterwards. So, but what I wanted to highlight is this term rapid transition, which sounds really corporate, right? But we've done such a lot of this stuff over the years. Whether it be inside toilets from sort of 1967, only 25% of homes in the UK had an inside loo. Now, most people, if there weren't two inside a property, you'd be going, oh, there's only one toilet, you know, if you're moving in somewhere, and you'd be thinking about putting another one in. So really interesting that we shouldn't categorize all this incredible amount of hard work we've got to do to get that consumer buy-in as though it's something that's never been done before. We have, and we've done it loads of times. We've just done it with different things. And that's a really important thing I want to sort of draw out. So other examples, gas central heating. I can remember not having any gas central heating or any central heating at all, in fact. But again, nowadays we just expect it as a norm. And it's very much about looking at that, looking at fitted kitchens. We never used to have fitted kitchens, but now we expect it as a norm. And the summary of that is that we are housing, our expectations, our demands, our consumer expectations of all sorts of things within the home have changed. And nobody ever considers payback on those things, which really gets me, because loads of people talk, what's the payback on a heat pump? What's the payback on this? Well, it's a means of heating the home. I don't absolutely understand there's a big capital cost for most people, but again, we need to try and flip that mindset into a why wouldn't we instead of why would we? And that's a really difficult social challenge. I get that, but if we don't, it could be tricky. And again, it's a social norm. Going back to 2011, 10 and 11, if you drove down the street and saw solar on the roof, you would probably stop and look up and go, oh, what's that eco bling on that roof? Whereas now it's everywhere all around the country, and we just accept it as a social norm, in the same way as if you flew over to Turkey or Spain and you see all the big solar thermal plants on top of the various buildings and blocks of flats out there. We just expect it's ordinary. And I guess one particularly for this group as well is about the visual impact of heat pumps, especially. And the bit that I always home in on that is, do we remember when we didn't have 17,000 different types of recycling bins outside our doorsteps? Because that's a really big social change, is to go from having one bin to having multiple. And I don't know how many there is in the areas of the people I'm talking to, but you'll certainly have 2 or 3, I would imagine, if not more. And having all of those stacked up outside the house, we've just become accustomed to in some areas, and that's our expectation. So yeah, the question is, why wouldn't we install a heat pump? And I guess the most recent one that we all will be aware of is the transition to LED lighting, where sort of 10 or 12 years ago, LEDs were very poor, they were very expensive, not a lot of people were using them. Whereas now you pretty much can't buy anything apart from an LED lamp. And that's a really rapid shift change in 10 years practically. So we shouldn't be too upset that it's taking a little while to get to 600,000 heat pumps by 2028. That's not going to happen. So think about it. Why wouldn't we have an inside loo? That's the sort of comparators we've got to give, and somebody's paying for that. Somebody pays to have the inside loo, directly or indirectly. When you buy a house, when you're retrofitting a home, somebody's physically chosen to do that. So a few little bits and pieces about the social challenges, because I thought that might be quite an interesting set of topics to go around. There's a very common misconception, I feel, about heat pumps being noisy. I noted a few people, I think it was Frank, talking about oil in Hovingham. Almost every heat pump now that's available on the market, the terminal noise, that's the velocity noise that we hear from the fan moving, assuming it's been installed correctly, right? And I get there's those cases as well, but assuming it's installed correctly, is actually technically less noise than a fan-assisted oil boiler flue, and probably less noise than an older conventional gas boiler flue. There's no other way of getting people to realize that without seeing it, feeling it, touching it, and actually getting in front of one while it's running. So what I would say for anybody is, if you've got people in your community that are happy to sort of do a heat pump open day, or just, you know, take a look at my heat pump kind of session over a weekend or something, it's a really cool way of getting engagement with people. They do have to have their heating on flat out during that time, obviously, so the heat pump's running. But it's a really good way. A little note in there about planning GPDO. You may or may not be aware there's certain planning restraints around deploying heat pumps at the moment in the UK. I will absolutely categorically guarantee you they will disappear in the next 6 to 12 months. There's already been a technical case study review by that with a lot of very clever acoustic engineers. And I would also say that we seem to have, believe me or believe me not, you've only just met me, we seem to have some coherent government joined up thinking on some of these strategies between various departments. So between whatever we're at now, DLUC, the Department for Local Housing, etc., and BEIS are getting together. External box, so that's a bit I touched on before about this aesthetic look. You know, again, going back 10, 15 years, they look very, very box shaped, weren't very nice looking. Yes, I also understand that some of the more modern units, if you look at the Octopus Cozy 6 unit that looks a little bit like a pink salt bin, that may not be for everybody, but manufacturers are working quite hard to make them look acceptable to people as well. Well, one of the biggest things that we come across with social challenges is disruption during installation. There's a lot of people make inquiries about heat pumps. So we were involved in the Department of Energy's deployment under something called the Electrification of Heat program. So that was 750 heat pumps installed for free across England and Scotland, I think it was. And we audited 242 of those. The biggest cause of dropout for engagement were people who, when they had the survey around, realized that there'd be likely to be a number of disruptions to their home, swapping out radiators, swapping out pipework, etc. Probably one for a deeper discussion, but I can absolutely categorically guarantee that the disruption that we are forced to accept at the moment is more down to the lack of technical ability of those doing the surveys and the designs of the systems, and wanting a very simple take a package and fit it kind of approach, rather than doing some complicated maths to see what would work within the existing dwelling. So again, that's a time and education thing for the installers, the surveyors, the designers, but we don't here at GTEC, we don't put that in a very high risk category at the moment, because we very much believe that will get flushed out in the due course as people get better educated. And then a little bit about how the heat pumps work. So I'm just going to throw this over mainly because if I keep talking like this, I'll run out. So does anybody just want to try and tell me what does a heat pump actually do? Anybody want to chip in? No. Nick's looking like he's leaning into the screen. I'm not looking for any complicated Carnot theory, mathematics or anything.
Is it basically a fridge in reverse?
Yeah.
Okay, so it's actually just a fridge, right? That's all it is. Forget the reverse bit. But the point to hone in on is that it does exactly what the name suggests, and it pumps heat. That's it. That's as much as you need to know and understand about it. It pumps heat from one place to another. So taking the fridge example, I suspect, like me, some people on this call may be old enough to remember when you could see the sort of aluminium or stainless grill at the back of the fridge, actually inside the compartment. That you don't tend to see them anymore. And then you've got the black grills at the back, which give off heat. That's a heat pump, right? So all it's doing is taking out the warmth from your sausage roll or your whatever you put into that fridge, and it's absorbing it into that grill at the back, and it's pumping it out into the black grill at the very back of the heat pump. And that's done via that very big black sort of homogeneous block that you see usually bolted at the back of a fridge or a freezer, and it's literally just pumping that heat. But it does that in quite a clever way, and I thought I'd just run through this very quickly, that it takes that heat and it takes it into a liquid, and because of the way the pressures and stuff work, it actually boils it up to a gas. So we usually end up with a really, really high volume on the left-hand side. I'm not sure if you can see my mouse moving around as well. Can you? Yes, you can. Good. So that area there, it takes it from a very, very, very high volume of low-grade heat, and it boils off this liquid inside here, which is what we call the refrigerant inside. It turns that into a gas. The gas moves around and into this compressor, and the compressor compresses it. Now, I'm imagining, unlike many of my calls, there's a number of people here who are quite keen cyclists. And if you think of this in the same way as when you're pumping up a bike tire, and the hand pump will get hot, right? Because you're squeezing all of that energy into one place, and the heat pump's doing exactly the same thing, and it's pumping and compressing that heat, and we get some hot gas over at this side here. And in a conventional heat pump, what actually happens is the water that goes around the radiators starts circulating alongside it, and off it goes to the radiators. That then cools it down, it condenses a bit like you get condensate on a window, and then takes it back, and it goes through that cycle again and again and again. 4 parts, really, really easy. 4 parts, not complicated. And if I asked anybody to tell me when did their refrigerator last break down, I would imagine it would be quite a long time ago, right? Because they are inherently really, really reliable. By the way, I don't sell heat pump systems anymore, and I'm equally as keen on these as I am other technologies. There's different applications for different things, but that was today's particular topic. So it is literally just pumping heat. What it looks like in a bit more detail is something like this. So we've got the compressor, which is that big black box. We've got low-grade heat coming in. Now, if that's ground source, that might come in from a loop of water going around the ground or in a vertical borehole. Or if it's air, it'll just be passed over the fins, if you've seen a heat pump, on the back of the heat pump. And in there, that creates the boiling gas. The boiling gas now gets compressed. The compression goes over to this exchange part here, and that's when we go off to the emitters or the radiators, the underfloor in a home, and away we go. And it just carries on that cycle all day, every day. And that's sort of what it might look like in terms of an atypical installation in a home. And the bit that a lot of people get upset about, absolutely understandably, is the disruption part around the pipe work. You may be moving from a combi system onto having a cylinder, etc. We sort of can't get away from some of that. Certainly the cylinder part, it's almost impossible to install a heat pump without requiring a cylinder. But there's a lot of work going on in radiators and piping to help get rid of that disruption. And then another one to sort of kick some myths out is the idea that radiators aren't really any good for heat pumps, which is completely fabricated. Again, it comes down to the maths, but there's a really interesting nuance that's happened over the last sort of 20 years especially, is that when heating systems were sized originally and installed, you would end up with people who have the right size radiators, or actually probably usually slightly oversized. And then as time's gone on and that home has become slightly more energy efficient, so there's some insulation being applied, maybe underfloor, maybe windows have been changed, maybe there's work done to seal up air gaps and drafts and that kind of thing. Actually, what you find now is for a conventional fueled system, oil or gas, those radiators are far bigger than they actually need to be, and they'd work quite well with a heat pump. But again, and trying not to be too disingenuous to installers, that requires some maths to do that, and a lot of them just prefer to do the option of just coming along, replacing everything, and going from there, which isn't ideal for consumers, and we see probably a 70–75% dropout of consumers at that stage. So then that moves us nicely into the sort of technical challenges. And again, we're really blunt about this. There's no technical challenges at all. I've designed systems with heat pumps that have gone into churches. Right? Churches aren't usually inherently the most insulated or airtight buildings, but absolutely anything is possible. But an interesting point here is about what we perceive to be efficient, because a lot of people talk about, is a heat pump efficient? Is it going to run efficiently? So I thought it'd be worthwhile just drilling into that a little bit. So, and again, I don't know on the call whether anybody is sort of in this space, but is anybody able to guess a little bit about what the average efficiency is of a gas boiler? Anyone aware?
70%.
70 is, that's probably quite realistic, Chris. I'll be honest. Usually the government and co would have you believe it's kicking around 85–90%, but when you take into account how it's actually installed, yeah, 70–80% would be fairly average. But what about a heat pump? And I'm talking about a really badly drop kicked on a Friday afternoon, no consideration to the customer installed heat pump. No, probably around about 300%. And in fact, the building regulations now require a minimum of 300% efficiency. So um, just to highlight there that when we use the term efficiency, from an engineer's perspective, a heat pump will always be more efficient. What we're actually talking about, which is critical to the customer, the consumer, is about the running costs, right? But we shouldn't confuse the running costs with efficiency. And it's a really important part I like to sort of distinguish, because the worst installed heat pump from the worst manufacturer that you've bought from Temu or AliExpress or whatever will always be significantly more efficient than a gas boiler, even the best gas boiler.
Can I just understand?
Sorry,
Sorry,
Mark.
sorry. Can I break in and just understand how something can be more than 100% efficient? That doesn't quite make sense to me as a non-engineer.
Yeah. No, that's fine. It's a really good question. So what we're looking at is primary fuel in and energy out, and it differs slightly for those two. So when we're talking about gas boiler, we're talking about a cubic meter of gas that we pay, what is it now, 6.5, 7 pence maybe, depending what tariff you're on at the moment. And I might pay that amount of money, and then I get so much thermal energy from that delivered into the home. Okay. So I'm looking at the fuel in, or the cost in, because obviously the fuel and the cost are related, and then the amount of thermal energy into the home. With a heat pump, what we're doing is we're using electricity. So that's denoted in kilowatt hour terms. That's our unit of energy. I'm sure everybody's sort of aware of that on this call with your particular experiences. And that is then used to drive the heat pump, which is collecting, and I'm always careful about how I say this, but it's collecting the free energy from outside. So what we're actually doing is using our cost of energy is actually to bring it inside, rather than to burn it and create, or you can't create energy, but burn it and convert that energy from a gas to a heat source. So for every 1 kilowatt hour of electricity to drive a heat pump on a badly installed system, I would expect 3 kilowatt, the term is actually kilowatt therm hours, to be delivered into the property. So hence the term, we say it's 300% efficient. Does that help with that? That makes sense?
It does. Thank you. It's brilliant.
Yeah,
Thank you.
no problem. So what we're actually talking about, quite rightly, is running costs, right? That's a kicker. So the other part is capex, or cost of the unit itself. And again, if you were to ask me to build a heat pump from scratch, I'd say give me 600 quid and I'll go and build you one, right? Because the constituent parts are not actually that expensive. Everybody's looking aghast there. I hope nobody's had a heat pump installed recently and has paid the market rate. Again, what we've got to remember is we are in heat pump world in an absolute tiny minority of the heating market in terms of what's getting installed, and the scale, the economies of scale are just nowhere near where they need to be to make it effective. And quite rightly, no matter what we might think about certain big corps, if they've spent 2, 3, 4, 5, 10 million on R&D on a product, building new production lines, shipping them, etc., they have to get that money back, or R&D will stop and we'll never get any products that are better. So, but we have to get to that pinnacle point where it starts dropping off. But I just wanted to highlight that unit there, which is an air-to-air unit, right? So some of you may have these, some of you may have worked in offices that have had these. It's a heat pump, and it's actually a heat pump that requires 2 boxes. Now, in my world, that means that I've got double the production line time to accommodate for. So if I've spent £1 million on my factory, and I've got 2 boxes coming off it, that means, or for one system, I'm getting 1 system per £1 million. Whereas with a heat pump, because both of those are in 1 box, it's 1 production line time. It's a lot cheaper to manufacture. Pretty much we can swap out that unit there and say that that's the bit that exchanges the heat to water, and just look at the price. And this is an absolute random website. I don't have any special terms with them, and it's 1,600 quid for 7 kilowatt peak system. Yeah, which hopefully reinforces the point about the cost of the parts. What I can also tell you is I know some manufacturers of heat pumps that are grade A manufacturers that are landing their heat pumps in Hull at £1,200 per unit for a unit that will do the average 3-bed home. So there's also a supply chain discombobulation as well, and people making money in what's a minority market at the moment. Mark's grabbed a calculator. Oh no, there's going to be a tricky question coming in a minute. And then just very briefly, moving on to the running costs. We've got to get to a point where the running costs are acceptable, and that means almost parity for people on what the fuel is are trying to displace. So I've used some examples here of 6.5 pence for gas, 8 pence for oil. I totally understand that's quite sweeping because lots of people pay lots of different prices. That's not 8 pence per litre of oil, by the way, because those days have long gone. That's 8 pence of kilowatt hour delivered from the oil itself. There's some maths that goes into the back of that, which I can pick up with anybody if they desperately want to. So what we then assume is if I've got a SCOP of 3 or an efficiency of 300%, if I get my good refrigerant running at 55 degrees, that means I probably don't need to replace many of my radiators. So that means that I'm running at 24 pence divided by 3, because I'm getting 3 times as much thermal energy for the electrical energy that I'm pushing into that particular unit. So that the real key here is that's 8 pence per unit of heat delivered, which is still higher than probably, I mean, I know there's been a reduction recently on natural gas, but probably less than gas, but it is actually matching or less than oil for sure. And again, in terms of tariffs, I'm sure people in this group are 100% aware there's a lot of very snappy, sexy, dynamic, time of use kind of tariffs going on at the moment. And I'm intimately aware of the colossal amount of work which really big corporates are doing in this space to give priority heat pump tariffs that mean that the running costs will equate to or be less than that of a conventional fuel. I absolutely have no doubt that that will come in very, very quickly. I'm aware of beta trials where they're doing that already. So that then brings us really back to the CapEx and the social queries. And a lot of that, I'm afraid to say, could be driven by some bad installations. And I think, Kate, you want me to sort of highlight some of the things we needed to look at. What does good look like? What does sort of bad look like?
Yeah,
these are some examples.
That'd be great. I'm only just a little bit conscious of
Oh,
time.
we're running over.
Just
Okay.
to see if anyone's got any questions. But I don't know how much more you want to.
You'll get the pictures afterwards, right?
Oh, okay.
In the
looks like some
slides,
dodgy
so
things going
just
on.
have a look through. There's some things to look out for, which I'm sure, you know, uncontinuous insulation, etc. Then please fire that off. And then it was a little bit about installer availability and consumer access to tools, etc. What I'll finally wrap up with is, you've seen we've got a dedicated centre up in North Yorkshire. We are 100% open door to anybody who wants to come. So if anybody here wants to gather a group together, we've even built inside, we've built a house for people to come and have a look at for insulation. We've got solar PV, we've got energy storage, we've got heat pumps coming out of our ears. We've even got some solar thermal, because I still love solar thermal from back in the day. And we're quite willing to do talks for people, etc., in a completely unbiased way. I understand what you said, Frank. I'm not doubting those people weren't unbiased, but if somebody's struggling to get hold of a presenter, then we're more than happy to do that. And I'll wrap it up there.
That's brilliant. Thanks so much, Griff. It's just really interesting to hear sort of different side of heat pumps, and sometimes you hear with all these myths and things. So I'll just see if anyone's got any questions for you. Anyone got any questions?
That's
Yes,
great. Oh, no, that's one.
Sorry, was that me, Kate?
Yeah, go for it. Yeah.
So what's got to change then, Griff, to make the uptake quicker? I mean, are you basically saying that it's government that's got to step in here?
So I think what we have to be brutally honest about, and you alluded to it a little bit earlier, is what gets people involved, right? I've been doing this for 20 odd years, and like you say, it's the same faces. I go to events now all over the country, giving talks and stuff about this transition. What I see is a lot of very new faces. And honestly, the only reason why they're engaging is because there's a business case. So we need to be really brutally honest about that and say, whilst we are all in this space now to want to reduce carbon, decarbonize, whatever you want to call it, net zero, we used to call it renewables, whatever it is, we've got to hit it full on and say, actually, what the consumer wants is something that works at a cost that is acceptable to them in both running and capex up front, because that's what's going to get the mainstream engaged.
And to your point regarding the using power at a different rate, we use 70% of our electricity now in the house at 7.5 pence a kilowatt.
Yeah.
Okay, overnight. So the air source heat pumps on, kicking out heating up the hot water, doing the dishes, doing the laundry, charging the car. It's doing all of that at 7.5 pence a kilowatt.
Yeah, which if you couple that with a heat pump and an energy storage system, which is the bridge, it means that you can run your heating any time of day.
Yeah.
And still be using that. Now, if you put that back into that sum, that means that your heat delivered is 2.5 pence per kilowatt therm, right?
Exactly.
Which means that it's probably, if you take into the efficiency of gas, probably 35-40% cheaper, or sorry, 60% cheaper than gas would be. And that will drive people to buy the product. And an interesting parallel is that if you purely installed solar on its own right now, usually the costs don't stack up, right? You're not going to see the returns that we used to. You'd have to get really involved with energy storage and snappy tariffs and exports and stuff like that, which for most consumers don't want to. But there's 20,000 solar PV installs going in each month, every month on a domestic scale alone. I know that 95-97% of those wouldn't financially stack up, but we've overcome the social barrier and people are now just saying, I'm choosing to have it. Don't get me wrong, there will be a big capex debate around heat pumps as well, but lots of companies are coming in, the likes of Aera, Octopus, SMS, KKR, who are all doing heat leasing. So you'll effectively pay a £80-100 a month and your house will be lovely and toasty, and that'll be it. Just like you'd rent a kit, buy a kitchen, lease a kitchen or a bathroom or whatever else. So slightly different models, but they are really, really well developed now.
That's lovely. Well, thank you. Is it a quick one, Christine? Because I'm really keen to make sure Nick has enough time to do his talk.
It's really quick, yeah. Is there a register of trusted suppliers?
No.
No.
There's the MCS register.
It was quick.
There's the MCS register, and I chaired that standards committee for 9 years. There's a very good reason why I stepped down. My honest belief is at the moment you can't trust them. The best thing to do, I'm afraid, is word of mouth and build up a local knowledge base of those installers who are trusted. It's really awful for me to have to sit here and say that, but I'm afraid the regulatory schemes in the UK at the moment are not great, I'm afraid.
Okay, thank you.
Lovely.